In this video, we're going to look at how to factor expressions using log rules. So if I have an expression that has logs in it, right, we can factor using variable replacement as a helpful tool. However, we can't do that if our logs have different bases or if our logs have different arguments, or sometimes if we end up having like an exponent inside of our argument. So I would use log rules to help me simplify my expression if I see that we don't have the same argument or we don't have the same base. Now, if I take a look at the first one, it says factor as fully as possible. I've got 10x ln x. Ln is just log base e, and then we are subtracting ln squared x. Now that square is on the whole thing, so that's the same as ln x and then all squared. So if I wanted to factor this, I notice we have the same base. We're doing log base e or ln, and we have the same argument. That exponent is not on the argument. So if I have the same argument and the same log, like the base, then I can just use some variable replacement and factor this. So I might choose to take out the ln x and let that be a. You do not have to use variable replacement here, but I do find that it helps. If I take that out, I get 10x and then times ln x, which is a, so I have 10x times a, and then I'm taking away ln squared x, or a squared. All right, taking a look at this, I do have two terms. I do notice that they have a common factor. They both have an a, so I can common factor out the a, and then I would be left with 10x from the first part, right? 10xa divided by a is 10x, and then a squared divided by a is a, so I'm going to get a times 10x minus a. Now, all I need to do is put back in the ln x, and I will get ln of x, and then times 10 ln x. Oh, nope, that was 10x, and then minus ln a. I don't know where my correction tape is, so I'm just going to have to cross it out. All right, sorry about that. So this is just 10x, let's just cross the whole thing out. So I have 10x and then minus ln of x. And then that would be my final answer in factored form. All right, in our second one, I have 10x ln x minus ln x squared. So when I look at these, the logs do have the same base. They're both log base e, but they do not have the same argument. This one is x, and this one is x squared. So there is a difference here. The square is on the argument, whereas here that square was on the whole log. So this is when I would look at using a log rule to find another way maybe to write this. If I take a look at my log rules, I do have this one here that says that when you have an exponent on your argument, you can bring that exponent down out front as a coefficient. And if I do that, it should make it so that the arguments are now the same. So I'm going to leave the 10x times ln x the same. And then here, I'm going to bring that 2 down in front and say minus 2 ln and then x. So now that we have the same base, same argument, I should be able to factor. You might see from here what you can factor out. If not, I would suggest maybe doing some variable replacement. So if I let a be my ln x, that means this is going to be 10x times ln x, which is now a, or 10xa, and then take away 2 ln x, or 2a. And I notice 10 and 2 both divide by 2, so they have a 2 in common, and they both have an a. So I can take out a common factor of 2a, If I do that, I would get 5x and 1. Okay, all I need to do at this point, now that it's factored, is put the ln x back in. Let's see if I can do a better job of that than on the last one. So I have 2a, so that's ln x, and then times 5x minus 1. So I have 2 ln x times 5x minus 1. All right, I'll see you in the next video.